Hey guys, Mr. Martin back here again with today's video on how to find and use slopes of lines. I know that sounds like an Algebra 1 topic, but we're going to actually apply that to geometry. So here we go. Alright, just by way of review, got some key vocabulary. You guys remember that the slope of a non-vertical line, meaning a line that does not go straight up and down, is the ratio of the vertical change, which we called the rise. So the rise is the vertical change, to the horizontal change, which is the run. So you guys remember it as rise over run, or the change in y over the change in x, between any 2 points on the line. So you can pick any 2 points on the line, find the difference in the y's and the difference in the x, and that will be your slope. Okay? Alright, couple key concepts also from Algebra 1 days. You remember that the slope of a line that falls or goes downhill from left to right is negative. So this line that goes downhill has a negative slope. The lines that go uphill have a positive slope. The lines that are perfectly flat have a zero slope. And the only one that we cannot find the slope of is the one that goes straight up and down. And we say that is undefined. Alright? So, you guys remember all that from Algebra 1. Let's look at the geometry part of this. Okay? But before we do that, I want to just make sure we can calculate slope. So let's do the slope of line A. You see line A goes through the points 6, 4 and 8, 2. So let's calculate the slope of line A. Okay, if you remember, we just subtract the y's, the difference in the y's or the rise. Okay, goes on the top. Don't forget that's the rise. It goes on top. So you can see the difference from 6 to 8 is the difference of the x's, and the difference of the y's is 4 to 2. So a couple different ways we can do it. First, we can say that this is actually a fall from 4 to 2, and then a positive run from 6 to 8. So that's why we end up with a negative slope. Another way to do it is we can say that it's actually a positive rise if we go from 2 to 4, and then it is a negative run if we go from 8 to 6. So whether you start at the point 0.64 or you start at the point 0.82, it doesn't matter. You'll still get the same slope. Alright, let's do line D. Okay, so line D goes from 0.64 to 0.60, and you can tell that line does go straight up and down. So we already know from the previous slide that that is going to be an undefined slope, but let's just go ahead and do the calculations. So we see the change in the y's is from 4 to 0, and the change in the x is actually 0. So the change in the y's is right here, goes down from 4 to 0, but you notice it does not move left and right, so the change in the x's is 0. So we end up with a 0 on the bottom, and you know that the only number that we cannot divide by is 0, and that's why we end up with a slope that is undefined. Okay, just to clarify that and to keep remembering things like that from Algebra 1 days. Alright, let's look at the geometry part of this. So a couple postulates, things that again that we accept as being true without necessarily having to prove them. Okay, the first one is the slope of parallel lines. We say in a coordinate plane, two non-vertical lines are parallel if and only if. So again, this is a definition. So parallel is if and only if they have the same slopes. So if they have the same slopes, they're parallel. If they don't have the same slopes, they're not parallel. Okay? Alright. Let's look at perpendicular lines. Oh, and by the way, two vertical lines, two lines going up and down, even though we really can't calculate those slopes, we do say that two vertical lines by definition are parallel. Alright? Let's look at perpendicular lines. Now this might be a little bit new for you. Okay? We say in a coordinate plane, two non-vertical lines are perpendicular if and only if the product of their slopes is -1. Okay? And remember, we find product by multiplying. So if we take the slope of the blue line in this example and multiply it by the slope of the red line, if we get -1, then they're perpendicular. If we get anything else, or if we do not get -1, then they're not perpendicular. Alright? And by the way, a horizontal line is always going to be perpendicular to a vertical line. We accept that just as definition. We don't necessarily cannot prove that because the slope of a vertical line is again undefined. Okay? Alright, let's do an example with parallel lines. So I want to know from this picture which of these lines, if any, are parallel. Okay, so remember we said if the lines have the same slope, then they're parallel. If they don't have the same slope, then they're not parallel. So this is some good practice. Go ahead and calculate the slopes of each one of those lines. Pause the video and then come back and we'll see which lines you think are parallel. Alright, so let's find some slopes. Let's do line K1 first. Okay, so the slope of K1 is 4. Is that what you got? Okay. How about K2? That is also 4. So we know since we have two lines with the same slope, those two lines are going to be parallel. So we can say that K1 is parallel, and remember the sign for parallel is two lines that look like they are parallel, is parallel to K2. Okay? How about the slope of K3? Alright, so the slope of K3 is 5. So obviously 4 doesn't equal 5, so we say that K3 is not parallel to either K1 or K2. Okay? Again, if they're parallel, they have the same slope. If they have the same slope, they're parallel. Alright, let's do an example now with perpendicular lines. So I want to find the line that's perpendicular to line H. Now, line H runs through the points 3, 0 and 7, 6. So the first thing we need to do is we need to find the slope of that line. Because remember, the product of the slopes has to be -1. So in order to find the slope of the perpendicular line, I have to know the slope of the original line. Okay? So the slope of the original line, which was what we called line H, will be 3 over 2. It was 6 over 4, but we reduced that to 3 over 2. So what is the slope of the perpendicular line? Remember, we said that the slope of the two lines has to be -1 if they're perpendicular. Now remember, the sign for perpendicular is the upside down T. It literally looks like two segments that are perpendicular to each other. Okay, so we know the slope of M1 is 3 over 2. So 3 over 2 times what is going to be -1? Well, let's divide both sides by 3 over 2. And you remember we divide by a fraction by multiplying by its reciprocal. So it's going to be -1 times the reciprocal is 2/3. So the slope of the perpendicular line is going to be a -2/3. And just to verify, we can multiply those two together. 3/2 times a -2/3 gives us a -6 over 6, which is -1. So it does in fact check. Okay, so we know the slope of the new line, or the line perpendicular, has to be -2 over 3. Okay? So now we want the line perpendicular to line H to go through 2, 5 and have a slope of -2, -3. So we can go to this point 2, 5 and we can count down 2 and right 3 and we can find a new point. Okay? So we go to 2, 5, we count down 2, right 3, we find a new point that the perpendicular line has to pass through, and then we connect the dots or draw a line through those 2 points. Okay, so the 2 new ideas for this unit are the idea that lines that are parallel have slopes that are the same, and lines that are perpendicular have slopes whose product is -1. So make sure you got good notes. Take a second and try to process all everything that's in the video. Don't just write stuff down that you don't understand. And come to class on Monday ready to discuss these new ideas and do some practice problems. And we'll get this solidified in your knowledge bank. All right, have a great weekend, guys, and we'll see you on Monday.